At this point, we're going to start talking about our idea of geometric figures, where by geometric figures, we just mean shapes. A geometric figure is what you get where you draw sides by tracing from a point and ending up back at that point, where rigidity means things more like polygons and curves get to things more like circles, but we'll talk more about that later. For now, we're going to start with the most basic of our polygons, the triangle, where the triangle is the result of a shape like this, where you have three distinct line segment sides. And one of the most fundamental properties of the triangle comes from a result called Euclid's theorem, where Euclid's theorem says that the sum of angles in a triangle, any triangle, will be 180 degrees. And remember back from chapter 1, we said that the conclusions we get from deductive reasoning are what we call theorems. So let's try and actually deduce our way to why this theorem happens to work. And the reasoning, or at least the most common reasoning, is built off of a very important piece of logic that changes if we stop thinking in terms of the nice Cartesian space of points and lines, but that's way beyond this class, at least excepting for the people who do the extra credit. But, topology is scary. Anyway, for this, the result that we have to build this off of is the idea that if we are given a line and a point not on the line, there is one and only one line that we can draw through the given point parallel to the given line. So that is, if we have some point and some other line below it, the line that goes through the point there that is parallel is unique. This is an important property of the space we're working with here that actually doesn't hold more generally. But like I said, that's a different topic. Point is here, when that works, what we can do is take that pair of parallel lines and the point and draw two transversals that hit the top line at the point we started from, that we generated this whole construction from to get a shape something like this instead. Where if we have a shape like this, hopefully we can tell that for one in the middle there we have a triangle, and then that we have the angles 2, 5, and 4. Those will have a sum 180 degrees. They'll have the sum 180 degrees because they are supplementary. They break the straight line, the straight angle, into three parts. It's a little bit different than what we saw with the two parts, but it's the same basic idea. And then from there, we can also use the idea of alternate interior angles to say that 2 has to be equal to 1, and 4 has to be equal to 3. So the three angles that make up our triangle in the middle there, 1, 3, and 5, following that label scheme, must have a sum equaling 180 degrees. And that is our argument there. We could be a little more rigid about how we call these things arguments and all that stuff, but won't worry about it too much for now. Instead, what we're going to do here is look at a way that we can use this information here, this piece of foundational geometric logic, to find the measurements of the angles of a triangle when we don't have all the pieces. So for this, we want to find the measure of angle A for the triangle ABC, where here we are given the measure of angle B is 120 degrees. So we want to be specific there. M of B is 120, along with the measure of angle C. M of C is, in this case, 17. It's an odd one, but hey, it's what we've got. And then from there, we can use Euclid's theorem that says the total measure is going to be 180 degrees. So the measure of angle A plus the measure of angle B, 120, plus the measure of angle C, 17, is going to be 180. And then from there, we just subtract 120, we get 60, subtract 17, and we get that the measure of angle A is going to be 43 degrees. Pretty straightforward to use Euclid's theorem if we're given our two parts, but we're not always necessarily given the two parts. We have some more general things we want to deal with here. And so next, what we'll look at is the way that we can classify triangles based on, well, their angles, as well as some other important properties that we have when dealing with them.